Good afternoon. This is Rich Nass, Executive Vice President of Open Systems Media and leader of the Embedded Computing Design franchise, here for this week's Embedded Executive Podcast. This week, my guest is Paul Denisowski. He is a product management engineer for Rohde and Schwarz. How you doing, Paul?
Good, Rich. How are you?
I'm doing just fine. Thank you very much. I wanted to speak to you because, from what I understand, you're an expert on a subject that I get confused about, which I sort of think that the audience is confused about, and that is EMI in general, but EMC is often confused with EMI, and I want you to explain what the difference is. Then I want to get into some of this pre-compliance testing that has to do with EMI. So I've just given you a lot of stuff to talk about. So let's start with EMI versus EMC. What's the difference?
Sure. Well, I'll just say that a lot of people use those terms interchangeably, even though they're not the same thing. So, in a nutshell, EMC is electromagnetic compatibility. So, it's do things interact well with other things around them, and you can split that up into EMI and EMS. The EMI is electromagnetic interference. In other words, does this device interfere with other things? And the other half side of that would be EMS, is susceptibility. Do other things interfere with your device? So, that in a nutshell is the division between the two of them.
Okay. So I want to talk to you about pre-compliance testing, but isn't that a no-brainer? Don't you have to do the pre-compliance testing? I mean, you don't want to wait till later to be doing that testing, right?
Exactly. Well, it depends on who you ask, because some people do wait till later, and it gets them into a lot of trouble. You don't have to do pre-compliance, right? Compliance testing you do have to do, but pre-compliance is a really good idea, and I think over time, more and more people are starting to see why it's so important.
But if you don't do the pre-compliance and then you fail later,
It's
that
going to
sounds
cost
like
you
a
a lot of money, yep,
yeah,
and
it sounds
time.
like a pretty big problem.
It is, and a lot of people, for the first time, the reason I've been talking about this recently is a lot of people don't realize that failing a compliance test is actually kind of a big deal. It costs a lot of money, it takes a lot of time. You don't get to troubleshoot on site usually. So it makes a lot of sense for people sort of to do a practice test, if you want to think about it that way, before they go to the compliance test.
Why does it cost a lot of money if you fail the compliance test?
A couple of reasons. One is the compliance test itself costs money. So, that obviously you got to pay each time you take a test. The other one, really, the bigger issue is the cost of redesigning. You take your device, which is done, or you think it's done, get it compliance tested, and it fails. So now you have to go back and redesign and re-engineer. And that whole redesign, re-engineering process costs a lot of time and money. So it costs real dollars, but it also costs a lot of engineering and debugging dollars.
If you pass the pre-compliance test, are you guaranteed to pass the compliance test?
It depends. In some cases, pre-compliance and compliance are really close. Conducted emissions. So, is your device putting out things that shouldn't be putting out over like the power cord? Those are usually pretty close. So, if you pass what we call a conducted pre-compliance test, the odds are pretty good you're going to pass a compliance test. Radiated, where the signals are over the air, that's a little iffier. But I will say that if you fail pre-compliance, you're definitely going to fail compliance. It doesn't necessarily work the other way around.
Right. So what sort of devices are we talking about that should be put through these tests?
Well, it's really what devices have to be put through them. I mean, almost everything electronic, and this goes for the US, Europe, all around the world, it has to meet certain limits. The FCC specifies them. The European Union has their specifications. There are hundreds of specifications.
So
But pretty much every consumer device has to pass these tests.
but you could pass in one geo and fail in another?
Yes, you can actually. That does happen. It's the standards are kind of harmonized that they overlap, but not 100%.
So is it fair to say that you should be adhering to the strictest standards so then you'd pass everywhere? Or is
Yeah,
that
that's usually a good idea. That's what I would recommend.
and who has the strictest standards?
That also kind of depends. Depends on how you look at it. Honestly, the strictest standards usually are the military standards. Believe it or not, the military has very strict standards for certain things for devices they use. But it really depends. Like automotive may be stricter in some parts of the world than other. Consumer devices like hair dryers or washing machines might be different. It really just kind of depends.
And is Rohde involved in all of these various devices, or
Uh,
is there an area of expertise?
we pretty much do it all in the sense that the same instruments and tools and techniques are used for all of them. It's really the limits. Okay, you must be below this or that at this frequency that are different.
Okay. And what's the hardest devices to get through?
Oh, goodness gracious. I mean, it really is hard to say because the devices themselves, it's nothing particular about a device so much. It's more the engineering of the device. There are 100 different ways, for example, you can build a power supply, like a wall wart that's used to charge things. And really, it's the design that makes it fail rather than the nature of the device itself.
And is there something in particular where you say, where you can look at it and say, I don't even have to look at this. This is going to fail.
Anything without the mark on the outside of it, if you look on the back of an device, they have all these little markings on them. If it doesn't have those markings, it probably is going to fail. And
Good.
even if it has the mark, it may fail. But the easiest way to tell is, does it have the mark? I mean, really, you're supposed to have the mark on it before you can sell it.
So you have to have the mark to sell it. There's not things on the market that have failed.
Well, there are. I mean, there are things on the market that would fail if they had ever been tested and they weren't. But in most parts of the world, you can't sell things unless like it has a CE mark in Europe, and without that mark, you're not supposed to be able to sell it. From my own personal experience, we've seen lots of devices that have been sold and eventually caused problems because they were actually failing the tests.
Now, are these things that are that have failed, is that a danger to a person, or is it just just that the device might not work right?
In most cases, it's just, I'll call it annoying. You may have a device that interferes, for example, with your television or with cell phones. There have been lots of cases, though, where failing EMI has resulted in cars crashing, planes crashing. So it is a serious thing. Those are rather dramatic, but they're also rare. But the effects can be anything from mild annoyance to potentially damaging or life threatening. So yeah, it's important.
So what's your advice to somebody? What's the starting point?
Do pre-compliance testing. I mean, it's cheap. I mean, compared to the cost of running a single compliance test in a lab, you could buy a basic pre-compliance test setup for that amount. Do the testing. It's important for that reason that you want to pass, but also a lot of engineers think of EMI as an afterthought, like let's make the device and see if it passes. Once you start doing pre-compliance, which you run, you start to think about it more in the design process and start working this into the design, and that's really, really valuable, I think.
Is it simple enough that Joe Engineer can do this on his own, or does he need to call Rohde for help?
Well, we're always happy to help, but frankly, it's pretty simple. That it's well understood. There's a lot of material out there to learn about it, and a lot of the tools come with I'll call it wizards or setup guides or software where you basically plug and play. So really, it's not that difficult. You don't have to be a genius. I'm certainly not.
And do you offer the tools to do this?
We do. I mean, we as Rohde and Schwarz offer the instruments, the antennas, the accessories that are needed. But again, the same instruments and accessories can be used for all kinds of pre-compliance testing. The instruments tend to be kind of similar for everything.
Good deal. I think you've just saved some people some time and some money. I think this has been educational, certainly for me, but for the audience for sure.
Well, I appreciate the chance to talk about it. It's an interesting subject, and I would encourage people to go out and learn more about it if they are designing or manufacturing pretty much any kind of device.
I agree. That was Paul Denisowski. He is a product management engineer at Rohde & Schwarz, and I am Rich Nass with Embedded Computing Design. Thanks, Paul.
Thanks, Rich.